Hey guys, welcome to Learn Today IGCSE. This video is a tutorial on Chemistry Paper 4, Variant 4-2 from February-March 2025 examinations. Question 1. Using numbers only, state the percentage of oxygen in clean dry air. Now, the approximate composition of clean dry air consists of 78% nitrogen, 21% of oxygen, and the remainder is a mixture of noble gases and carbon dioxide. Next, the typical operating temperature in degrees Celsius used in the Haber process. Haber process is the manufacture of ammonia, and some of the operating conditions that you have to know is that it operates at 450 degrees Celsius at a pressure of 200 atm, and the catalyst used is iron. The other process that you have to know is contact process, so make sure you also learn the operating condition of that process. Next, number of atoms in a diatomic molecule. Diatomic molecules means you have two atoms in one molecule, and monoatomic molecule means you only have one atom. The maximum number of electrons in the second electron shell of an atom. The first shell of an atom can only hold a maximum of 2 electrons. The second and third can hold a maximum of 8 electrons. Next, question E. Number of hydrogen atoms in an alkane with 7 carbon atoms. The general formula for alkane is CnH2n plus 2, and N is the number of carbons, so it will be C7. H2 times 7 is 14 plus 2 is 16. So for 7 carbons, you would have 16 hydrogen atoms. And lastly, the number of particles in 1 mole in standard form. This is the constant for Avogadro, which is 6.02 times 10 to the power of 23. Next, question 2. This question is about ionic compounds. State what is meant by the term ionic bond. If you look into your course specification, under chapter 2.4, you will see that ionic bond is defined as a strong electrostatic attraction between oppositely charged ions. Next, question B. Potassium sulfide is an ionic compound. Complete the dot and cross diagram in figure 2.1 of the ions in the potassium sulfide and show the charges on the ions. When you are asked to draw a dot and cross diagram, make sure to look for your proton number. For potassium is 19 and for sulfur it's 16. For atoms, the number of protons is equal to the number of electrons. So the electron configuration for potassium is 2881 and for sulfur is 286. So when reacted together, potassium is going to donate 1 electron giving a charge of positive 1, and sulfur will receive another 2 electrons in order to become a complete shell. So the charge is negative 2. So to complete the diagram for potassium, you need to draw one more shell as there are a total of 3 shells, and the third shell has 8 electrons. And sulfur, on the other hand, has 3 shells as well. 2 has been drawn for you. You just need to add another one. Initially, on its own, it has 6 electrons. And to become a complete shell, it received another 2 electrons from potassium. So we are going to draw a dot to show that it has gained the 1 electron that potassium donated. Next, question C. Ionic compounds form giant ionic lattices. Part 1. Figure 2.2 shows part of the giant ionic lattice structure of sodium chloride. Complete the diagram in figure 2.2 to show the ions present, positive for sodium ions and negative for chloride ions. 1 chloride ion has been completed for you. So negative will be attracted to positive. So just make sure to draw opposite charges connected to each other. Next, part 2. State the name given to any positive ion. When an atom donates electron, it forms a positive ion. And the term given to this is cations. And for negative ions, we use the term anions. Next, question D. Ionic compounds can be decomposed by the passage of an electric current using inert electrodes. Part 1. State the name of this process. Electrolysis is the process of breaking down an ionic compound in molten or aqueous solution using electricity. Part 2. Write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide is decomposed by the passage of an electric current. The ions present inside a molten potassium bromide is K plus and Br minus. Molten means that there is no water molecule present, means no H plus and OH minus. Now the positive ion will be attracted to the negative terminal, which is the cathode, and the negatively charged ion will be attracted to the positive terminal, which is anode. Now electron flow out of negative terminal into the positive terminal. So at anode, you can see that electrons leave or electrons are donated. So bromide will donate electrons electron to become bromine. Since there is 2 bromine, we'll balance it by writing 2 bromine. Now this gives us 2 negative charges. Therefore, we'll balance it by writing 2 electrons. Next, part 3. Name the products and state the observations at the negative and positive electrodes when dilute aqueous potassium bromide is decomposed. Okay, now the question changed slightly. Instead of using a molten solution, you are now using an aqueous solution, meaning that the ions present right now would be H+, K+, OH- and Br-. So the negative terminal will attract H+ and K+ as opposite charges attract each other, and the positive terminal will attract Br- and OH-. Since this is a diluted solution, we will choose the ion to be discharged based on the electrochemical series. Hydrogen is placed at the lowest of the ECS, and for the negatively charged ion, hydroxide is placed in the lowest of the ECS. So the half equation for negative electrode would be H+, negative electrode will receive electron, so it receives electron to form hydrogen gas. To balance it, we'll put a 2 like this. And for hydroxide, you have to memorize the half equation, whereby 4 hydroxide will release 2 molecules of water, oxygen, and 4 electrons. So the product at negative electrode is hydrogen gas, and the observation, since this is a gas, you will notice colorless bubbles, whereas for positive electrode, the products are water and oxygen gas. And again, since gas are produced, you will notice colorless bubbles. Next, question 3. The halogens are a group of elements in the periodic table. Chlorine is a member of this group. State the group number of the halogens. All the elements in group 1 can be known as alkaline metals, and all the elements in group 7 are identified as halogens, whereas group 8 are called as noble gases, and all the elements from group 3 until group 12 are known as your transition elements. So the group number for halogen is group 17. In your syllabus, you can also call it as group 7 because usually the transition elements are excluded. Next, question B. State how many halogens there are in this group. So you've got 1, 2, 3, 4, 5, and 6. Next, question C. Suggest the identity of the halogen which has the highest density and the most reactive. As the element goes down the group, it gets heavier. So the element at the most bottom of the group has the highest density. And as the elements move up the group, it is more reactive. And as it goes bottom, only for group 7, it becomes less reactive. So the most reactive would be fluorine. Next, question D. State the name of the negative ions formed by halogens. When halogens form negative ion, we call them halides. Question E. State how many occupied electron shells there are in a bromine atom. As you can see, bromine atom is placed in period 4. This is period 1, period 2, period 3, and period 4, which is on the 4th row. This means that it has 4 shells that occupy electrons. So the answer is 4. The number of period in your periodic table determines the number of shells that has electrons. Next, question F. Name the noble gas which has the same electronic configuration as a bromide ion. A bromine atom has 35 protons, which means that it also has 35 electrons. However, for it to become stable, since it is in group 7, it will receive another electron to become 36 electrons. So a bromide ion has 36 electrons, which is the same as krypton atom, which has 36 electrons. So the answer is krypton. Next, question G. Aqueous chlorine reacts with aqueous potassium iodide. One of the products formed is iodine. Part 1. Complete and balance the ionic equation for the reaction between chlorine and iodide ions. State symbols are not required. Now, the reactivity of group 7 is such that as it goes down the group, it becomes less reactive. So this reaction is between chlorine and potassium iodide. As you can see, chlorine is placed above iodide, meaning that chlorine is more reactive compared to iodine. So when chlorine reacts with a compound that consists of iodide, it can displace iodine to become KCl and leaving iodine all by itself. So the ionic equation chlorine Since it's without partner, it will just be Cl2. The element of I here is combined with potassium, so it has a charge, which is -1. And then the chlorine here, since it combined with potassium, it now has charge. And the charge is Cl-, leaving iodine by itself, so it has no charge. You will just write iodine, I2. And now let's balance this equation. Since there is 2 iodine molecule, we will write 2 here. Since there is 2 chlorine molecule, we will write 2 here. This is balancing. Next question, part 2. Explain why this reaction is defined as a redox reaction and give your answers in terms of electron transfer. Redox reaction is when reduction and oxidation takes place simultaneously. So in this scenario, we can see that chlorine here goes through reduction and the iodide ion is oxidized. So this is a redox reaction. Next question, part H. Give the color and state of iodine at room temperature and pressure. So you can take a screenshot of this. You are required to know the physical state and color for group 7 elements. And iodine is gray in color in room temperature. And the physical state at room temperature is solid. So the color is gray and the state is solid. Question 4. Carbonyl chloride is manufactured by reacting carbon monoxide with chlorine. So this is the reaction and we can see that enthalpy change given is -105 kJ per mole. The negative symbol here indicates that the forward reaction is an endothermic reaction and this symbol tells us that this here is a reversible reaction. Okay, the process takes place in a closed system and an equilibrium is reached. Condition for this process is 200 degrees Celsius and 200 kilopascal. Question A. What is meant by the term closed system? A closed system is a system in which no substances can enter or leave. Next, question B. State what is meant by the symbol triangle H. This is the symbol for enthalpy change. Enthalpy change is the heat that passes into or out of the system during a reaction. Question C. State how the value of enthalpy H shows that the forward reaction is endothermic. So the value over here is always given for the forward reaction. Since there is a negative value, this means that this is an exothermic reaction. And if the enthalpy given here is a positive value, that means the forward reaction is an endothermic reaction. Next, question D. Deduce the value of enthalpy H for the reverse reaction. Include a sign in your answer. Now, if the forward reaction is exothermic, this means that the opposite reaction would be endothermic. So the reverse reaction is the opposite reaction. So the value would be positive 105 kilojoules per mole. Next, question E. Complete table 4.1 to show the effect, if any, on the concentration of COCl2 at equilibrium when following changes to the conditions are applied. Okay, COCl2 is the product of the reaction. So we are asked to find the effect on the concentration of product. Alright, the first change is that the temperature is increased. Now always remember that increasing temperature will favor the endothermic reaction. And in this case, the endothermic reaction is the backward reaction. So what happens here is that the position of the equilibrium will shift to the favor of endothermic, which is the left side. So we will have more reactants. So the concentration of the product will decrease because the product is on the right side of our equation. Next, some carbon monoxide is added. Carbon monoxide is one of the reactants. Now, increasing the concentration of reactants will shift the equilibrium to the right, which then favors more formation of the product. The product is on the right side. So this means the concentration of COCl2 increases. Next, the pressure is increased. Now, increasing pressure will favor the side with fewer moles of gas. Let's see. COCO has 1 mole, Cl2 has 1 mole, and COCl has 1 mole as well. So the total number of moles on the left side is 2, and the total number of moles on the right side is 1. As mentioned previously, increasing the pressure will favor the side with fewer moles, in this case towards the right side. So this means that the equilibrium will shift to the right side. If the equilibrium shifts to the right side, this will favor the formation of product. So the concentration of product increases. Next, a catalyst is added. Catalyst has no effect on the position of equilibrium. So that means the concentration of product or reactant, anything at all, will have no change. A catalyst added will only increase the rate of reaction, which is the speed of a reaction. Next, question F. The equation for the reaction can be represented as shown in figure 4.1. Table 4.2 shows some bond energies. Use the bond energies in table 4.2 and the value of enthalpy to calculate the bond energy in kilojoules mole for the CO bond. So we are looking to calculate the bond energy of this particular bond. Use the following steps. Calculate the energy needed to break the bonds in the reactants. Okay. In the reactants, we have one CO3 bond, which is 1075 kilojoules per mole, and we have one ClCl bond, which is 240 kilojoules per mole. Before the arrow here are your reactants. So we will just add them together. So the energy is 1350. The units are given to us here. Next is to calculate the energy released when the bonds in carbonyl chloride form. Okay, energy released when CO bond formed is over here. So we are looking to calculate how much of energy is this. Now the energy used to break the bond minus the energy used to form the bond is how we are going to get the change of enthalpy. So if we are looking to calculate the bond form, we're going to rearrange the formula to calculate the bond form. So the bond broken is 1315 minus the enthalpy is 105, giving us 1420 kilojoules. Next step is to calculate the bond energy only for the bond of CO. Okay. In the reactant is that we have 2 CCl and 1 CO. So we have 2 CCl bond. 1 CCl bond is 340 kilojoules. Adding with 1 CO bond, when you add all of this up together, we get the energy released, which is 1420. So to get the CO bond, we'll just take 1420, bring this value over here, and we will get 740 kilojoules per mole. Next, question G. Complete the dot and cross diagram in figure 4.2 of a molecule carbonyl chloride. Okay, we've got chlorine atoms with an electron configuration of 287, carbon atom with an electron configuration of 2 and 4, and oxygen atom with an electron configuration of 2, 6. And we just need to draw the outer shell of the electrons. Chlorine has 7 electrons on its own and needs 1 more electron to be stable. Since it's overlapping with carbon, it means the 1 electron that it needs should come from carbon. And carbon has 4 electrons, meaning that it needs another 4 electrons to be stable. Oxygen has 6 electrons and it needs another 2 electrons to be stable. Since carbon and oxygen is overlapping, the 2 electrons that oxygen needs should be shared by carbon. Now carbon needs 4 electrons. That means it can take 2 from oxygen and another 2 from chlorine. And now we'll draw the rest of the electrons. Chlorine has 7 electrons on its outer shell. We have already drawn 1 over here, so leaving us with another 6. Oxygen has 6 electrons. We already draw 2 here on its outer shell, so we need to draw another 4. And now if you look at each of them individually, you will have a total of 8 electrons. That's 8 for oxygen and there is 8 for carbon. Next, question 5. Manganese is the element with atomic number 25 in the periodic table. Calcium is the element with atomic number 20 in the periodic table. Part A. Complete table 5.1 to show the number of protons, neutrons, and electrons in the manganese atom and the calcium ion. The atomic number is also the proton number of an element. So calcium has 20 protons and manganese has 25 protons. The number at the top here is your nuclear number, which is the sum of proton plus neutrons. So to get the neutrons, you will just take your nuclear number minus your proton number. In this case, 55 minus 25, which is 30. And for calcium, it will be 42, take away 20, which is 22. Since there are no charges here in your manganese, this means that this is an atom. For atom, the number of protons will be equal to the number of electrons. So there is also 25 protons. However, for calcium, as we can see here, there is a charge and it is positive. Positive means it has donated electrons. And the number of electrons donated is 2. So an atom of calcium also will have 20 electrons. But after donating 2 electrons, we are only left with 18 electrons. Next, question B. Manganese forms several oxides. The formula of some of these oxides are shown. Part 1 suggests why manganese is expected to form colored oxide. As mentioned previously, the elements in group 3 till group 12 are considered to be transition elements, and manganese is in the transition elements. There are several transition elements properties that you should know of. They can form colored oxides, they have different oxidation number, they act as catalysts, and they have high melting point and densities. So the reason why manganese is expected to form colored oxide is because manganese is a transition element. State which are the property of manganese is shown by the formation of several oxides. That property would be manganese having different oxidation number. Next, part 3, state the formula of manganese oxide. As you can see, the bracket here is Roman 2. This tells us that the oxidation number for manganese is 2+, and oxygen is -2. So when formed together, the top number here would go to this side and the top number here would go to the opposite side, giving us Mn2O2. When simplified, it is just MnO. Next, question C. Manganese oxide is found in an ore of manganese. Manganese metal can be extracted from manganese oxide using aluminium as the reducing agent. Part 1. Define the term reducing agent. Here's the definition for both oxidizing agent and reducing agent that you should know of. Next, question part 2. Complete the symbol equation by inserting the formula of the missing product and balancing the equation. So, aluminium will take over manganese to pair up with oxygen instead. Aluminium has a charge of 3+ and oxygen has a charge of -2. So when combined together, the 2 would go here and the 3 here, giving us Al2O3. Now let's balance it. We've got 3 oxygens here and 4 oxygens here. So to balance it, I'm going to put 4 here and 3 here. So now we have 12 oxygens, both left and right. Putting a 3 at the front here gives us 9 manganese, and putting a 4 in front of Al gives us 8 aluminium. And now the equation is balanced. Next, question part D. Manganese oxide reacts with dilute hydrochloric acid as shown in the equation. Calculate the volume of chlorine gas formed in cm³ at room temperature when excess manganese oxide reacts with 50 cm³ of 2 mole per dm³ HCl. Use the following steps. Calculate the number of moles of HCl. So there are 2 formulas to calculate the number of mole. The first one is mass over relative atomic mass, and the second one comes from the formula of concentration equal to mole over volume. Since we are looking to find mole of HCl, we are given with concentration of HCl and volume of HCl. So this is the formula that we are going to use. Rearranging this formula, it will be concentration multiplied by volume. The concentration is 0.2 mole per dm³. However, the volume given here is in cm³. So cm³ to be converted to dm³, we're going to divide it by 1000, giving us 0.05. So the mole would be 0.01. Next, determine the number of moles of Cl2 formed. As you can see here, there are no information given for Cl2. So when you are asked to find number of mole when not given any information, you can use stoichiometry to solve this. We have got the number of mole of HCl, which is 0.01. So we're going to use the ratio of HCl to chlorine gas. There are 4 HCl to produce 1 Cl2. So 4 mole of HCl will produce 1 mole of Cl2. So for every 0.01 mole of HCl, we get 0.0025 mole. The next bullet point is to calculate the volume of Cl2 formed. It has been mentioned here that we are looking to find at room temperature. If you are asked to find at room temperature, we can just use the formula of mole multiplied by 24 dm³. Is 0.6 dm³, but we are asked to give your answer in cm³. So we're going to multiply this by 1000, which is 60 cm³. Next, question part 2. Describe a test for chlorine gas. It's by using a damp blue litmus paper, and the observation is that the blue litmus paper will be bleached. Next, part 3. Explain, in terms of collision theory, why decreasing the temperature decreases the rate of this reaction. Decreasing the temperature will reduce the kinetic energy of the particles, which causes the particle to move more slowly and collide less frequently, which leads to only fewer particles having the activation energy, therefore only a fewer successful collision. And the last question here is on organic chemistry, question 6. The structural formula of two compounds A and B are shown. If you have a double bond, it means that your compound is an alkene. A and B are members of the same homologous series. Question A. Give two reasons why the structural formula of A and B show that they are members of the same homologous series. Because they have the same functional group and they have the same general formula. Both of them simplified gives us a general formula of CH2. For each carbon, there is 2 hydrogen. Hence why they have the same general formula. Next question B. Explain why A and B are both hydrocarbons. Hydrocarbons means they only consist of hydrogen atoms and carbon atoms. Write the simple equation for complete combustion of A. Combustion means that it reacts with oxygen to form carbon dioxide and water. If the question asks you for incomplete combustion, then it's the same thing. It reacts with oxygen, but it produces carbon monoxide and water. So that's the difference, and pay attention to that. Whenever you write a chemical equation, please be sure to balance your equation. Next question D. Deduce the empirical formula of A. So empirical formula is the simplest formula. As discussed previously, when simplified, they will form CH2. Name compound B. Compound B has 4 carbon. A 4-carbon alkene is known as butene. A structural isomer of B is a member of the same homologous series. Draw the displayed formula of this structural isomer of B. Remember that the maximum bond that carbon holds is only 4. Next question G. Compound B reacts with aqueous bromine at room temperature to form product C. State why this is an addition reaction. An addition reaction means that you don't have any other side products. Next part 2. Describe the color change in aqueous bromine during this reaction. So bromine water is initially brown, but as you can see, it has combined to become into one compound. So from brown, it has turned colorless. If this same reaction of bromine was reacted with an alkane, there will be no reaction because alkane is saturated. So the observation is that the color of aqueous bromine, which was initially brown, will remain unchanged. This is a famous test to see if alkane and alkene can go through addition reaction. So please remember the observation. Next, name product C. Product C is butene becoming butane since it lost its double bond by accepting 2 bromine. So once it accepts the bromine, it will be dibromo. Di because there are 2 bromine. Next question H. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. Carboxylic acid D has 2 carbon atoms. Draw the discrete formula of carboxylic acid D. It says that this carboxylic acid only have 2 carbon atoms. A carboxylic acid has a functional group of COOH, and this is the first carbon atom. So another carbon atom can be drawn at the side here, and to complete it, we will fill it up with 3 hydrogen atoms. So the name of this carboxylic acid, since there are only 2 carbon atoms, it will be ethanoic acid. Next question part 3. Complete the symbol equation for this reaction. So 1 mole of B, this here is 1 mole of B, reacts with oxygen, so O2, and it forms 2 mole of ethanoic acid. That will be COOH, and over here we have CH3. Now there are a total of 4 oxygens in this side of the equation, so we'll balance it by writing a 2 over here. And this is your final symbol equation. Alright, that's all for this video. Thank you so much for watching. Bye!